So firstly, when you're looking at the integration factor method, now integration factor method is basically also referred as solving linear differential equation. Now, when you're looking at linear differential equation, they'll be of the format dy by dx plus a function of x times y equals to a function of x. So this is a very much standard form, a dy by dx plus a function of x times y equals to function of x. Now here, since I have already discussed with you all like what exactly is integration factor and how do we get this, I'm just telling that the integration factor is something which is referred as e to the power integration of p of x dx. So if you integrate this function p and raised to power e, we get something called as integration factor. So sometimes when I look at the equation, like here I'll take a parallel example, is that the equations are not in the standard format. And in that case, you need to make the equations in standard format. So first thing what I do is, since you see that the derivative dy by dx term has the coefficient of coefficient as 1, so I'm going to make the coefficient of dy by dx 1. So divide this entire equation by ln x. So it's basically going to become dy by dx plus 2 over x ln x times y equals to 2x minus 1 ln x the whole square. So this is your integration linear differential equation. Now I'm going to find out the integration factor for this. So identify p of x is 2 over x ln x and q of x is 2x minus 1 over ln x the whole square. So this I basically got by dividing entire thing, both side by ln x. If I divide by ln x, divide by ln x each term. So you notice that this is what you get here. Now, if I integrate this to the power of 2 over x ln x, that's what is your integration factor. Now, this part needs to be integrated by substitution. So if I integrate this separately, 2 over x ln x, I take, let's say, u as ln x. So u as ln x, so du by dx is going to become 1 over x. So dx is x du. So once I get this, I'm going to plug out here. So it'll become 2 over x ln x. So ln x is u here into x du. X and x can get cancelled. So it is 2 ln u plus c. I mean, you don't need to put a c here. So this integration is basically e to the power of 2 ln u, or you can say 2 ln of ln x, you can say. So it is e to the power 2 ln of ln x. So now if you bring back this to power, so what you get is e to the power 2 ln x here, ln x the whole square. If you look at the value of this, it is simply ln x the whole square. So this is the first part, which is finding out the integration factor method. So after this step, once you find the integration factor, ideally you multiply both the side by integration factor. So you ideally multiply e to the power integration p of x dx, both the side. And as a result of this, you will notice that what you will get is, you will get something interesting. You'll get the left-hand side as the derivative of y times integration factor equals to q of x times integration factor. So this is something that is the magic of using integration factor. So this by default, now for example, I have got ln x the whole squared. If I multiply both the side by ln x the whole squared, see what do we get is basically, you'll get dy by dx ln x the whole squared plus 2 ln x over x, basically because if I multiply this by ln x the whole squared, one of the this get cancelled, so you get 2 ln x upon x times y equals to 2x minus 1, because this ln x whole squared, if I multiply with ln x the whole squared, it gets cancelled. So far we got till here, and if you notice this very clearly, this is the product rule on if you see derivative, this is nothing but derivative y times ln x the whole square. Blindly you can write down equals to 2x minus 1. So what I meant by this is that if you look at, this is basically the product rule. This is the product rule on y times ln x the whole square. So dy by dx times ln x the whole square is just like u dash v plus uv dash. So this is the first step what we've got so far. Now I'm going to basically, so I'm just going to rewrite the same expressions. We got dy by dx as, y times ln x the whole squared. I'm just rewriting it equals to 2x minus 1. So this is the step which we had got here until here. Now, once you get this step, you just integrate both the sides. So it'll be y ln x the whole squared equals to integration of 2x minus 1. So this I can just say, like, in your mind, just remember that the general solution of any linear differential equation is integration of y. So the main step is that derivative of y times integration factor equals to qx times integration factor. And one more step, if you go and if you integrate both sides, the y times integration factor is q of x times integration factor dx. So this is how you kind of do the integration. Now, if you integrate this, you get x squared minus x. So there's 2x squared upon 2 minus x and plus c, of course. So this is the y ln x the whole square. Now, of course, you divide ln x to the other side, ln x the whole square to the other side. So this part is basically now the general solution. But now you have been given that when x is 1, y is 2. When x is basically, in this case, you must be given a certain condition. So there is no boundary condition given here. So you just leave the answer at this stage. So as a summary of this, you remember that this is the main backbone of any linear differential equation. An integration factor is basically e to the power of integration p of x dx. So this is the basic skill that you need.